Alright, so let's just use this example here. We just found some reference angles. So I could ask you something like this. Find the cosine of 330 degrees. When it says an exact answer, essentially means you want something with a radical and no decimals. So cosine of 330 degrees, we just graphed 330 degrees, right? 90, 180, 270, you add 270 to 60, that gives me 330 degrees. I need to find its reference angle, which is a 30-degree angle. Well, the 30-degree angle, the reference angle, actually tells me that I'm going to use a special right triangle that involves a 30. Well, that's going to be a 30, 60, 90. And the shortcuts for 30, 60, 90s is that the smallest angle gives us the smallest side, so you can call that 1x. The biggest side gives us 2x, because it's essentially an equal out triangle cut in half. And then a 60-degree angle has x times radical 3. So this is a 30, that's a 90, this is a 60. That means going across a 30-degree angle, I'm going to write 1. Now pay attention. This 1 we learned yesterday is going down, so that's a negative 1. It's parallel to the y-axis, so that's called y. Y equals a negative 1. Across the 60-degree angle is radical 3. But notice that the radical 3 is parallel to the x-axis. It's going to the right, so it is a positive. And going across the 90 is a 2. And it is a distance, so you are going to have a 2 there. So again, 330 degrees gives me a reference angle. This reference angle tells me which special right triangle to use, and now I can just use my letters. Cosine is x over r, so cosine of 330 degrees is equal to x over r, which is radical 3 over 2. So my answer, if I had to find the exact value of cosine at 330 degrees, it would be radical 3 over 2. Now, yesterday we learned a phrase that helps us make sure that my positives and negatives are correct. Class, tell me the phrase. All students take calculus. So, in this quadrant, quadrant 4, what should be positive here? Cosine and secant. Do you see how that matches? Pay attention. A common mistake in beginning to start finding values is not using the negatives. Okay. Let's try this one over here. Let's change the problem to find tangent of negative 5 pi over 6. Well, if you think about it, negative 5 pi over 6, you could convert that to degrees. We don't have the unit circle yet. We're going towards that direction. And I know that this little reference angle is pi over 6. Well, if pi, think about it, pi going around is 180 degrees. Yes? So what is 180 divided by 6? 30. You can use the awesome proportion, but I just wanted to show you that basically that's a 30-degree angle. And then I could just basically use what I did in the previous problem. This is a 30, that's a 90, this is a 60. This is an x value because it's on the x-axis. I know it's going left, so it has to be negative. Across the 60, I'm going to use a radical 3. Here, if I drew a really big circle, the hypotenuse is my radius. My radius in this problem is going to be it's across the 90, it's going to be a 2. Now, the radius will never be negative because it's a distance, so it'll always be positive. And then across my 30-degree angle, I have a 1. My y is equal to 1. But now, pay attention, it's going down, so it'll be a negative 1. So for tangent, I know tangent is the letters y over x. So tangent of negative 5 pi over 6. My y value is negative 1. My x value is a negative radical 3. That does not make the math gods happy. We're going to have to rationalize there. So my negatives cancel. I'm going to multiply by radical 3 over radical 3. Tangent of negative 5 pi over 6. The exact answer is going to be a positive radical 3 over 3. I can double check my answer, my positive and negatives. Because I'm in quadrant 3, tangent and cotangent are positive. So, draw a picture, find your reference angle, use your special right triangle, fill it in, the sides, pay attention to positives and negatives, and you'll get an answer.